just started recording. So we're going to be recording the lectures and the labs. And basically, if, God forbid, one of you is not able to be here, you can watch the videos on Blackboard, and you can participate, or at least be able to watch the videos for the lab on Blackboard. Okay? So our go-to place for everything for the class is going to be Blackboard. And I'll share that with you in a second. Can you hear me just fine? With the mask on? So, Brent. Brent is present. Madison. Madison here? Not present. Caleb Chancellor. Caleb, speak up. Fabian?
Here.
Here. Let me see Fabian.
Fabian.
All right. Emilia?
Emily.
Emily. That's right. Okay. Brandon? Grady? Not here. Timber?
Here.
Is that how you say your name?
Mm-hmm.
Jake? Not here. Christian? Christian Lewis? Nicholas?
Here.
Nicholas, here. All right. Dakota? All right. Zachary? Excellent. Dean?
Here.
Name?
That's how you say it.
All right. John? I know it's hard. Charles?
Here.
Excellent. All right. So here's our Blackboard page. We're going to have two Blackboard sections. You go to your Blackboard, your classes are going to be listed under my Blackboard right here. And ours is going to be this one right here, as well as this one right here. Why do we have two sections? Because one is for the course, the lecture, and one for the lab. So, lecture, presentations, slides, handouts, reading material, all of that is going to be in the lecture one. Lab stuff in terms of template to write a report, your burn plan template, and we'll talk about that, is going to be in there. Guides in terms of the volunteer smoke management guidelines, in terms of prescribed burning introduction textbook, all of that is going to be in your lab section. All right? So, fire management. Here's the syllabus. Your Blackboard right here shows you basically what the book is, your textbook requirement. There's another book that is an alternative. I'm not requiring you to buy either book. They're just there for you to know what they are if you want to buy them. That first one is an excellent reference for you. It is expensive. I think last time I looked at it was like 900 something. So am I requesting you to buy it? No. All you need for this class is going to be handouts from the lecture, handouts from the lab, and basically some of this freely available information that we have online. It'll be all presented to you in Blackboard. All right. So, fire management. Why are we here? I'm Mohammad Bataineh, and I claim to know something about fire management, and that's why we're here, because you have to listen, right? Right? Come on. Why are we taking fire management?
To manage
fires.
To manage fires. What does that mean? How do we manage fires?
Use fire as a tool.
Use fire as a tool. For what?
To better manage forests.
Better manage forests. Okay, why do we manage forests?
It's an important resource.
Is that it? Just because it's important, we gotta manage it? Why do we manage forests? Why are you here? How many are in forestry options? 1, 2, 3, 4. Wildlife. 1, 2, 3. What about the rest? Undecided, GIS? Undecided? How many undecided? Just one? Okay. We're in natural resource management. So we're going to be managing those natural resources for a reason. What's the biggest reason we manage anything for? We manage a budget, we manage our kids. It's for a benefit of some sort, right? So we manage forest resources for a value that comes out of them. Either timber, wildlife habitat, we look at water quality, improvement of air quality, whatever that use, recreation. That's why we manage those resources. We gotta manage them in a sustainable way. What does that mean? Why do we manage in a sustainable way? What's all this hoopla about sustainability?
To reuse.
To what?
To reuse.
Okay. You gotta manage within the limits, within restrictions. You gotta be able to manage where that resource is not depleted over time. Because if it's depleted over time, yeah, I used it one time, but that's it. Right? That's why we're in natural resources management. Fire comes in handy for managing for timber, managing for wildlife habitat, and that's why you're in this class. You have to learn how to use fire to achieve a management objective. Whatever that management objective is. Some of those management objectives are exactly to fight wildfires. We fight fire with fire. So we go in and actually burn woodlots or forest land to reduce the hazard from wildfire. How many wildfires do we have in 2020? Do you hear anything on the news about wildfires?
Well, California is always on fire.
Yeah. What about Australia? Did you hear anything about fires in Australia? We had a really huge fire season in 2020. It was fire than COVID, right? So one of the biggest uses of fire here is to manage for that wildlife catastrophic, basically, consequences of wildfires. Some ecosystems are actually adapted to fire, and they demand that fire in order to be sustained. We have lots of those systems in the south. One of them being longleaf pine ecosystem. Without fire, longleaf would not exist. Shortleaf, without fire, shortleaf would not exist. It relies on that fire to create the growing conditions for that species to basically reproduce and perpetuate itself. Okay, that's why we're here, to learn about fire and using it as a management tool. My name is Mohammad Bataineh. My office is in D107, just across the hall. We're going to be meeting in here for the lecture and the lab. Most of our labs are going to be outside. We'll have some labs in the computer lab where we will use software. So in this course, you will get to have a hands-on, real-world experience with fire management. You will go outside, look at a forest stand, evaluate it, and establish basically how are we going to use fire to achieve the management objective that you're going to be handed as part of your assignment. So you will be broken into groups, and each one of your groups will actually go outside and play with fire. With that said, this is a class where safety is our #1 priority. So masks shouldn't be a big deal for us, as we have to basically obey our PPE requirement for having fires. So you will be issued a shirt and pants that are fire resistant. We got to make sure that we have what fits you. You will keep that outfit during the semester. You'll have 2 exercises where we'll have active fire exercises, meaning there will be fire on the ground. So you have to be vigilant, you have to be safe, and you have to come prepared with your equipment. So you'll have your issued Nomex outfit. Nomex meaning it's a material that is going to be fire resistant. You will need your own leather boots. You'll have to wear cotton under your Nomex outfit. No polyester, no nylon, nothing like that. You'll have to bring a mask for the CO2 and the vapors that we're going to be breathing while we're burning. And you have to wear a hard hat. So these are some of the requirements that come associated with this class. And they're listed in here as well. As I said, textbook not required. So, in terms of what I was talking about here, you have to have your proper attire. You cannot come to class or labs with sandals or shorts. If you do, you will not be participating in that lab. You will be asked to sit that one out. And your grade will be reflected in that non-attendance. We'll make it. Well, you have to learn exactly these 10 things. If you master these 10 things, you basically met the requirement for this class. So, you have to know the terminology. You have to explain how fuel, topography, and weather interact to determine fire behavior. You have to know how to compare and contrast how this fire behavior is going to change under these combinations, fuel and weather. You have to be able to describe the use of burning in natural resource management. Why do we do it? It's not out of no reason. How to distinguish among and apply suitable firing techniques. And this will be reflected in your prescription. You will write a plan. You will write a 30 to 40 page document that will spell out in detail why you're going to be burning an area, how you're going to be burning it, on what day, under what weather conditions, what kind of fuels do you have for that unit, and so on and so forth. You will go as far as describing the expected fire behavior from this planned burning. So, this prescription or this plan is going to be the ultimate goal of this class. We will have quizzes and exams. The ultimate goal is you writing that plan. You write that plan and you show that you have learned these outcomes. Your grade will be basically based on that plan, not based on everything else. In other words, just to be clear, I really didn't do well on my exams. I kept getting D's. But I got an A on my plan. That A will eat the C or the D that you got in your exams. Whatever grade you get higher, that's the one that you get assigned in the class. Okay? Fair? So you get a fair chance of getting the grade you want in this class. In terms of assignments, we will have 2 exams. I usually do pop quizzes. They're not announced. we'll have a final exam, and we'll have your prescription, and on top of that, you're going to have lab reports. So there's a lot of work in this class. And the way we have it designed is that each lab report is basically one section of your prescription toward the end. So if you paid attention in the labs and you actually wrote your report with thoughtfulness, that will feed into your prescription toward the end and will help you out immensely. Clear? The last date to drop is there. Everything else you need to know in terms of how the grades are going to be assigned is here as well. So this one is not showing that well. I'll go back and fix that. But basically, usually I do is 600 points for the class. But 200 points are assigned to your prescription. And then you have 100 for the first and second exams, and we have 100 on the quizzes. I'll fix that table for you. Here's our schedule. So we're hoping that we will be burning somewhere around the end of March, maybe mid-March, end of March, depending on weather conditions and how we're doing with the labs. The thing that you got to understand about this class that the dates are not set in stone. They will change based on if we actually burn or not. We will also have a fire behavior demos, and these are active fires. So right here in February, toward the end of February, toward the end of March, these are active fire exercises. Okay? Other than that, everything else is flexible. Questions so far? There's an addendum to the syllabus. It's also there, talking about midterm grades and all of that stuff. It's for you to read. I do want you to read this student conduct statement, because we'll definitely apply it in this class. Questions so far? So far, so good? We're still in the lecture. Our lives on Monday. Next Monday is going to be a holiday, so we're not going to have class or a lab. But the following Monday, we'll have our first lab. And it will be outside. So you have to come prepared with boots, warm clothes if it's cold, a hard hat, a vest. You're going to need an orange vest, you're going to need a hard hat. Okay? Clipboard, pencils. And here's our fire fundamentals. This is our first section for the class. And basically, if there's a video in the PowerPoint, it's also going to be repeated in here, so it's a little bit easier for you to watch those videos. There are a lot of videos in this class. Almost every lecture has a video. And it's not necessarily the lecture video, it's additional material that will help you understand the topic a little better. That should help when we are not being able to be on campus. All right, let's start talking about fire. So, when we're talking about fire, we're talking about the combustion process. And to understand the combustion process, we will actually break it down into phases, into divisions, into 4 divisions, no matter what those divisions are, just to simplify the process. You gotta remember that combustion is a continuous process, a dynamic process. So, once it starts, it's going to be changing over time. And that variability is not going to be really encompassed within one phase or the other. sometimes multiple phases are going to be occurring at the same time. But this is just a way for us to understand the combustion process a little better. We're going to be talking about heat. What is heat? What is thermal energy? And how is this thermal energy transferred across from the point scale, where we have it at the match level, all the way to within a stand, all the way through a landscape. These are pictures from the Tri Creek Fire in West Texas. This is the McDonald Observatory in West Texas, a multi-million-dollar, basically, place that is set on top of this mountain to look at the stars. When the fire went through, it basically jeopardized that structure. So fire means lost property, means loss of life, and basically we got to be able to understand how this fire is going to be interacting with this variability of fuel and having the consequences that we don't want to see. How do we stop that from happening? So we will literally go through the combustion where we are at that match level to the stand level where we are writing prescription. And then if you're engaged in wildfire management, you'll be looking at that landscape level where fire is basically having a perimeter, and the perimeter is advancing through multiple thousand hectares or acres, and you're basically trying to limit that expansion of that fire or spread of that fire over the landscape. We gotta know fire behavior, how it interacts with all of these variables, so we can actually control that effect of that combustion process, so we can actually control that fire. If we alter the fuel management when we're looking at stand and landscape levels, we can actually determine what kind of fire behavior we're going to have. In fact, this is how fire management started. Does anybody know anything about the history of natural resources management in the US? How did it start? Trying to protect it. That was our first thing. We looked at fire as a threat. Explorers and early settlers coming into the US, they want to protect those timber resources that they have that they're using to build homes and to homestead with. And basically, fire was looked at as an enemy. So, as we moved in time, our focus was so much on controlling that fire and hindering that wildfire activity that we actually came up with a national fire danger rating system. Have you ever passed through a community and looked at Arkansas Forestry Division unit and seen what's the name of that bear that is involved in wildfire? Smokey. Have you ever seen Smokey outside with a sign saying fire danger today is high or fire danger today is moderate? That's really where this came from. Our first attempt at fire management was just that. How do we basically classify fire danger, and how can we put a limit on this wildfire spread and the consequences that we get from wildfire? So we want to take advantage of those environmental conditions that allow us to conduct burning in a safe manner in order to reduce the effect of wildfire effects and in order to achieve a specific management objective, such as, okay, on a forest stand. Have you ever worked on a forest stand that had a lot of brush in the understory? Is that annoying or what? I can actually improve access with fire. Have you ever worked in a pine stand that had a lot of brush as well? But basically all of the trees were really small and kind of pine thicket-like. They were like matchsticks. You couldn't even walk through it. So I can actually reduce the number of trees in a stand cheaply using fire. And a lot of times, this cost effect comes into play. What I can accomplish with fire is a lot cheaper than what I can accomplish with chemicals, or what I can accomplish with actual mechanical means. I can go in and cut down those small trees, but how much is it going to cost? Oh, if it's labor, student labor, it's not going to cost anything, right? Oh, there is a cost involved there. But usually when we're doing timber management, what kind of equipment do we have to send? Have you ever seen any timber logging happening around here? What kind of equipment do we use? Any idea? A bulldozer that goes to the tree, holds onto it, cuts it at the bottom, flips it, and puts it on the side, right? A filler, buncher. That's what we use. Those things are not cheap. And they have to be moved from one side to another. So there is a cost involved in moving that equipment to achieve that management objective. Now, I can send Brent right here with a drip torch and some gasoline and diesel, and then you can accomplish the same exact thing without having to incur that cost. So, what is combustion? What is photosynthesis to begin with? Plants are doing what? They're taking carbon dioxide and water, combining that with solar energy to produce carbohydrates, biomass, plant material. They produce stems and leaves, crowns, roots, all of that good stuff. So, is this why we kind of have carbon sequestration talks, looking at basically locking that carbon into plant material? Yeah, because they're soaking it in from that air. So, this basically the presence of carbohydrate. If we have heat going in, what's going to happen? If we're heating that plant material, what's going to happen? That carbohydrate is going to be broken down into the elements that started to begin with. So we're going to have carbon dioxide, we're going to have water vapor. Question? Stop me and ask any questions if you need to. Okay, I'm going to take a second. Okay. Now, it's not just carbon dioxide, and water. There's also carbon monoxide in there. There are organic volatile compounds that are involved. There are basically particulate matter that is just small particles that are suspended in the air. When you look at fire and you see this white smoke coming out, what is that white stuff? It's mainly water, but it's mixed in with all of these other noxious chemicals that we have. So, photosynthesis is a building process. Combustion is the opposite. It's breaking it down. Now, this chemical reaction of combustion is called rapid oxidation. It's just basically using that oxygen and the heat to break down those plant material. So we're going to get heat, light, and smoke. And when there's smoke, there's fire, right? Why is it important to even care about smoke? We're managing fire. What about smoke? Who cares, right? Yeah, we do. Because if smoke covers our campus or covers our urban areas, what's going to happen to you put on fire on the ground? Who's going to complain? The public. And you're not going to be able to burn anymore. So we're not just interested in putting fire on the ground to meet that management objective. We want to be able to put it on the ground in an efficient and safe manner that mitigates the impact of smoke on sensitive areas and sensitive populations and does not result in catastrophic effects or damage to the resource that we're managing it in a sustainable manner. All right. Now, I said we're going to break that combustion process into 4 phases. And here's our first one. This is the first phase, and it's called pre-ignition. What do we do in pre-ignition? What happens? Pre-ignition this is where we have an endothermic reaction. An endothermic means it's inside, it's inward, so it's absorbing that heat that is presented. Okay, I'm in my fireplace at the house, having fun. I'm bringing in firewood. What do I have to do? I have to make sure that I have a pilot heat source. I'm bringing that pilot heat source close to the fuel. That is the logs in my firewood, in my fireplace. Now, that wood is going to start absorbing energy. That absorption of energy is going to raise its internal temperature to ignition temperature. Once that ignition temperature is reached, that combustion continuous that does not need pilot heat source process is going to start. Now, so my temperature is rising for that piece of wood. The moisture is driven out of that fuel. As temperature rises in that wood, you'll start smoking. That smoke is your moisture content getting out of that wood. Now, fuel is heated and dried in this preheating phase. Now, the heat, after that ignition, is going to start dividing that wood piece into its elements. So you're going to have basically gases and smoke, and you're going to have organic volatile compounds that are going to be distilled as resins and char and so on. So the fuel is going to start breaking down. This breakdown process, we refer to it as pyrolysis. What is pyrolysis? It's basically the breakdown of fuel using heat. So we're distilling that fuel into gases and other molecules using that heat. Now, that temperature kept on going, kept on increasing. We reached that threshold that is required to maintain a chain reaction. So it's usually around 600 degrees for wood. Once it reaches that 600 degrees, now that pilot heat source is no longer needed. I have reached ignition. Think of a rocket. We have basically the gases are being ignited. Once they're ignited, that ignition of one part is going to ignite the next, and so on. So we have that chain reaction going. We don't need that pilot heat source anymore. Now, so ignition, what is ignition? It's the transition between pre-ignition and combustion. We have a chain reaction going. 600 degrees, the pilot heat source is no longer required. Do we have a spontaneous ignition? Okay, to burn something, you have to have a pilot heat source. You have to have a match. Somebody has to start it, right? Some sort of heating has to occur. But do we have it where there is no direct heat applied? Do we have ignition? Anybody lived on a farm before? Okay? Have you seen hay bales go on fire? Have you?
Yes.
Okay, why? What's happening?
It's hot.
It gets hot. It reaches ignition temperature, ignites. That pilot heat source is not a necessity. If it reaches that ignition temperature, it's going to bring on that chain reaction, and it's gonna burn. Compost does that a lot if you don't mix it. Now, combustion. We have that chain reaction going on. How are we doing on time? We're good. So now, we're going from an endothermic reaction, a reaction that is sucking in energy, to an exothermic reaction that is releasing that energy. So, an example here would be your campfire or your fireplace. This process right here, or this phase of the process, we can break it down into flaming, combustion, and smoldering combustion. We use, in this class, we use glowing and smoldering combustion to refer to the same thing. So, the combustion phase, I have two sub-phases, one of them being flaming and the other being smoldering. From flaming, from the name, there are flames involved. What are flames?
Light and heat.
They're what?
Light and heat.
Light and heat. Yeah, they're those gases, basically, that are coming out of that wood, igniting, basically, and bringing in those beautiful colors that you see, of blue and orange and yellow and red. Now, what happens with, to a fireplace after 2 hours, after you put pieces of wood in it for 2 hours? What are you left with? The flames are gone. You're not adding any more wood. What's happening? Your grill. What happens after you put charcoal and you start it? You're having embers right there, right? You're having coals igniting in there, and you're cooking slowly on a lower temperature. Slowly, you're cooking in your charcoal grill, right? Smoldering. We don't have the flames, but we still have that heat being generated from that wood. So the fire now is acting on that piece of fuel or piece of wood, and it's actually degrading that components, the three components of wood. What are the three components of wood? What makes wood? Wood fiber.
Lignin.
Lignin. That's one of them, right? And this is the really hard material to burn and degrade and distill. So this stuff usually stays to the last. What burns faster than lignin? Come on, you know it.
Xylem, is that how you say it?
Huh?
Xylem? Think
No.
of that, secondary.
Carbon?
Okay. Carbon, what does carbon? In a piece of wood?
Cellulose.
Cellulose. Cellulose, hemicellulose, and lignin. That's wood. Cellulose is really white. It breaks down easily. So that's going to be the first stuff that basically degrades and produces those volatiles and produces your flames. All the way to lignin, that is going to be basically in punky material that is still holding on together by that lignin. And it's basically going to be smoldering and producing those whole embers that you have toward the end. So, flaming versus glowing or smoldering combustion. Smoldering combustion. Flaming is going to be rapid. It happens quickly because you have those gases. They ignite quickly. That duration of it is going to be quick. Glowing or smoldering, it takes a while. You leave the charcoal grill for overnight sometimes for it to cool down and lose all of those charcoals. Here, in smoldering, I'm having lower temperatures. It's consistent, but lower temperatures. In a flaming combustion, I'm having higher temperatures that are flashy. This is the wise and slow person, and this is the flashy and really kind of obnoxious responsive person right here. Think of it that way. This is going to be incomplete, meaning that that piece of wood is not going to burn completely, because it's just going to consume that cellulose at the top and leave the rest of it. In terms of smoldering, this is complete combustion. It's going to sit and eat that piece of wood, and you're going to have ash toward the end, right? Now, examples of this: fine fuel. Fine fuel meaning smaller sizes of fuel. Kindling is going to burn in that flaming combustion phase. Larger pieces, charcoal, logs, that's all going to go in that smoldering combustion. So, an example of that would be grass fires versus duff fires. What's duff? And it's not the beer that Simpsons drank. Anybody watch The Simpsons? It's not Duff beer, Duff fire. Not funny.
Isn't duff like the plant material?
It's the plant material that is where?
Under the grass layer, I guess.
Under the litter.
Yeah.
You have a forest floor with the litter layer on top, meaning basically needles, leaves, small branches that have not decomposed yet. But underneath that, you have a layer that is organic material again, but partially decomposed. All of that underneath the litter layer is a duff layer. Those duff fires are horrendous, especially from a prescott burning point of view. Because if I'm going to burn a stand, a forest stand, an area, I do not want to consume that duff fire unless it's specific in my objective. I want to burn that litter layer, but that's about it. If I start consuming my duff layer, I'm basically producing a lot more smoke. I am causing a lot more damage to my crop trees if I have any crop trees on that stand. So, grass fires. Have you ever seen a grass fire? How quick are those? Right? Especially if it's tall grass on a dry day. It doesn't take long to burn thousands of acres. Now, when it comes to timber stands, not just the fuel, there are other factors involved, but mainly fuel, that will result in a very much reduction of that spread that you see of that fire and the behavior of that fire. So this is why we want to know about the combustion process, because we want to analyze how fire is going to be behaving in those different fuel types that we're going to be encountering. Okay? Questions? So far? We good? All right. So, we have a pre-ignition, we have an ignition, we have combustion with its two subphases, and now we have extinction. What's extinction? Basically, fire is no longer going. It's stopped. It's a point which combustion ceases. It's a gradual process. It's going to happen over time. But basically, once that fuel is consumed, or there's no longer oxygen available, or that heat is no longer high enough to maintain that chain reaction, you're going to have extinction of that fire, and that fire is going to stop. Now, we need three things to have fire. The triangle, the fire triangle. What do we need? We need fuel, we need oxygen, and we need heat. You've learned this like when you were in elementary school probably, right? The three elements, the three sides of the triangle to get a fire. Now, this is great for the combustion process: fuel, oxygen, and heat. But when we're talking about fire behavior and differences in fire behavior in stands, we're talking about fuel, we're talking about weather, and we're talking about topography. So we refer to two triangles here. The fire fundamentals triangle, which is what you're looking at right here. And we have another triangle that we refer to as the fire environment triangle, which is basically weather, topography, and fuel again. They share that fuel side of the triangle. Okay, so how do we extinguish fire? We either remove the fuel, we basically reduce that heat or cool it with water, or we basically deprive it of oxygen. Okay, this one right here is great when we're dealing with urban house fires, industrial fires, that kind of thing. When we're talking about wildland fire, which is separate, we're mainly concerned with basically taking away fuel or taking away oxygen from those fires. How do we take away oxygen from fires?
Smother it.
We smother it with what? Blankets, right?
Dirt.
Dirt?
Some kind of chemical that could reduce
Fire retardant?
access to
Exactly.
oxygen.
And dirt. Our best tool is a shovel in fire management. There's a lot of digging of fire lines. Fire lines are basically just removing that fuel away from that perimeter of that fire. So, those zones in a fire can be matched with phases of combustion, or the phases of combustion can be matched with zones in a fire. So, we have scorch, flames, and embers. Scorch meaning that basically a fire started in a stand and it's heating up gases. The gases are reaching those needles and leaves. The needles are burning and falling down. Flames are the actual flames of the fire. And embers is basically that smoldering combustion that you have toward the end. So for scorching, we're talking about pre-ignition phase of combustion. Flames, we're talking about that flame combustion. And for embers, we're talking about that smoldering combustion. Questions? We still good? All right. We still have 3 minutes. I'm going to start this, hopefully. You know what? It's on Blackboard. You can watch it yourself. It's basically just what is a flame. Any questions on the class? What are we going to be dealing with? How are we going to be dealing with content or material? If you're not here, go to Blackboard. I'll post those videos as well. And it'll be within that learning module for that lecture. All right? We're going to have fun. We'll go outside and we're not going to have to be inside for too long.